All right. Now, folks, remember, if you're not interested in this problem, feel free to work on something else, but don't be a distraction to me or those around you. Right? We're just going to start with number 3. All right? So we got 2 identical charges, and they repulse each other with this, and their separation is this. What's the magnitude of each charge? All right. And yesterday, this Y was written for us, right? Different numbers, but same idea. All right, so we can start right in on the how. I'm going to go to my equation sheet and grab my electrostatic force equation. And now I'm going to substitute. I know one fact that Q1 equals Q2, right? Because they tell me that they're identical charges. So I'm going to just replace both those with the term Q. Yes? You okay with that? All right. So now I'm just substituting in what they tell me. F, they tell me, is 1.4 newtons. 8 Newton meter squared per coulomb squared. As always, Q squared, because I replaced each Q by Q. Do the math and I'm done. And there was much rejoicing. Questions? Sure, I can pause. All right, so on to number 11, where we're asked how much force is required to stretch a spring this far if the spring constant is this. Yesterday, this Y was done for us. Nice diagrams. We talked about how the forces should actually be touching the springs, but beyond that, and good information down there. So you have that document, so you can look at that. I'm going to start it here and start from my equation sheet. I'm going to get Hooke's law, since that has to do with springs and forces and how far they stretch and everything like that. One thing I'm going to keep in mind is that negative sign is reminding me that the force and the change in length are going to be in opposite directions. So I'm going to kind of drop that when I use this because I know that those are in opposites. So I'm looking for the force, I'm given the stretch, I'm given the spring constant. It really is as easy as substitute in my values. And then doing a little math, and I'm done. So there's number 11. All right, so we're going on to 5, where we have that point charge, the origin, where must an electron be placed for the electric force to be exactly opposite its weight. And you guys did the Y yesterday. Remember, this is one of the ones that needed some additions to it. It didn't have, the forces aren't labeled. It's unclear where like the Earth is and things like that. right? So this one needed a little bit of punching up, and that's okay. But realize that if you're using this to study, that this one's not 100%. So from my equation sheet, I'm going to grab two equations. I'm going to grab my electrostatic force equation and my gravitational force or my weight equation. All right. I'm waiting. What am I waiting for? Or is that not me? Okay. So, from my force free body diagram, I know the sum of the forces is going to be 0. Oh, sorry, I forgot the E down here. And I'm going to assume the electrostatic force is up. The gravitational force is in the opposite direction, right? Because they need to be opposites. That's the only way they're going to add up to 0. So my electrostatic force must equal the weight. So now substituting in from my equations that I grabbed on my equation sheet. And that's going to be the electron there. And now I can just substitute in all the values they tell me. They tell me that Coulomb's constant is 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. Oops. That's too close here. They tell me Q1, which is, I'm going to take as my fixed charge, so mine's 0.47. So 0.47 times 10 to the minus 9 coulombs. And I never would put in the negative because remember Coulomb's law has just to do with the magnitudes. And that negative is the type of charge, and it doesn't matter to me. 1.602 times 10 to the minus 19th coulombs. I know off the top of my head is the charge on an electron. I don't know how much they're separated. The mass of an electron is 9.11 times 10 to the minus 31st kilograms. And I'm assuming that we're on Earth, so the gravitational field strength on the surface of the Earth. Yes, sir. I just know that number. That's the amount of charge an electron carries, but it's given to you in the sidebar of the problem. Yeah, sorry. It's one of those numbers that sticks in my head. Too many years of looking it up. Finally stuck. Interestingly, they're saying your generation that won't happen to because you have Google. It's not worth your effort to actually remember things like that. You can always look them up.